Okay, 6.3 notes is over the introduction to being able how to read the unit circle, but we are going to have some building blocks before we start reading the unit circle, and we are going to begin this introduction by learning how to convert degrees of measurement into radians and vice versa. Now, one thing I want you to understand is that when we are dealing with the unit circle, it is comprised of like 3 different things. It's a reference sheet, so to speak. And this reference sheet that we call the unit circle contains angles that are measured in degrees or radians, and it contains the coordinates of points. And so we are going to tackle each portion of the unit circle little by little. And so let's start here with converting degrees into radians. Now, we will not do all the first 10 problems. We'll do a few as well as in the next section, and any of the ones that remain, that's for you to work on your own and practice. The answer key will be provided on Canvas or sent out to you. So let's start out with 220 degrees. Now, all I want you guys to understand is that all we're doing with these problems is changing the conversion unit, okay? So right now, 220 is given in degree measurement, okay? So for instance, if I asked you to measure the length of the page in front of you, okay? You can measure that length of the page in inches, or you can measure it in centimeters. No matter what measurement you used, you would still accept both answers as lengths in measurement, okay? The same thing goes for radians and degrees. You are more familiar with working in degrees, and as we dive deeper into pre-calc, you're going to notice that a lot of the measurements are going to be preferred in radian measurement. So I want you to make sure you memorize the following conversion. 180 degrees, so at the top of your page, maybe write this down, is the equivalent to pi radians, okay? 180 degrees is the equivalent to pi radians. Now, you will notice moving forward that the unit measurement word radians usually is not going to be displayed. You're just going to see 180 degrees equals pi, and you say the word radians even though you don't see it. It's understood and universally accepted, okay? So if I don't write the word radians, or RAD for short, just know that the measurement is radians, okay? Now we're going to convert 220 degrees into radians by multiplying it by a fraction converter, so to speak. And we're going to write 180 degrees in the in the denominator, and pi radians in the numerator. And the reason we're writing it in this format is because we would like the degree measurement to cancel, because we're trying to convert it into radians, okay? So you are going to be left with 220 pi over 180 degrees, okay? Now, I need you to make sure that you reduce this fraction. And what I need you to do is, when you reduce the fraction, I don't want you to put pi into your calculator. I want you to treat pi as a variable, unless they tell you to round the answer, okay? But if they don't say round, look at this problem right now, they don't tell us to round, it just says convert each degree into radians. Treat pi as a variable. So let me go to our calculator to show what you will do. So turn on your calculator, and we are going to type 220 pi over, I already forgot what it was, 220 pi over 180, okay? So first of all, you're going to press alpha y equals, and then hit enter, and it's going to create a fraction, okay? you're going to type 220. Treat pi as a variable, so do not put it into the calculator, even though pi is just 3.14. And now type 180. When you type it out and hit enter, you are going to get the reduced fraction. It's going to reduce it for you, okay? And you could have done that easily in your head, cancel out the zeros, and both numbers are even. Divide this by 2, divide by this by 2, and you get 11/9. So some of these fractions you can actually do it in your head. But anyway, so number 1 is going to equal 11/9, but just don't forget the pi that you ignored on the calculator. So 11 pi over 9 radians is your answer. Now, if they ask you to round in Delta Math, I do need you to put it in the calculator as far as the pi is concerned. So let me go back up here and hit enter. And I'm going to put pi here. If you are asked to put pi, now let me show you that screen. You are going to actually, right next to the 220, put the pi, and the pi is right here under the clear button. So if you see right here, it's in blue. So you will type second and then this button, and when you hit enter, you're going to get 3.839 and whatnot. So if, let's say, they're rounding to the nearest 10th place, you would just put 3.8. So going back to our here, if they ask you to round, it's approximately 3.8 radians, and this would be your answer. So just read your instructions and see which format they want you to do, okay? So let's do this one more time, and then I'll give you your problems to do. 920 degrees, multiply it by pi over 180, okay? So pi radians over 180. So notice I'm not going to write the word radians because it's understood. So that's just basically saying 920 pi over 180. So I'm going to reduce that fraction by typing 920 over 180. So alpha y equals, hit enter, 920, arrow down, 180. Notice I didn't type the pi, and I get 46 over 9. So my answer for this one would be 46 pi over 9. And then if I wanted to round it, I would type the whole thing into the calculator with the pi and get the decimal value. So I would like you to take a moment, pause the video, and why not do these 3 problems on your own, and then we will check your answers. Okay? So pause the video now and check back with me. Okay, if you're back, I have put the answers in pi format for number 3, 4, and 5. So check your answers, and I hope it turned out to be quite easy. So let's move on. So here you converted degrees into radians. You are able to do it in radian form where it's in terms of pi. Okay, so that's in terms of pi, and this is the rounded answer. Okay, so these are 2 different types of formats to finding your final answer. So read the instructions in terms of pi. Now, let us go to the bottom part here. Now let's convert radians into degrees. So again, we're going to do problems 11 through 20. We'll do 1 or 2 together, and I'll select 3 more for you to do. So let's write out the problems. So let's start here with pi over 6 radians. Okay, and now what you're going to do is instead multiply by the ratio pi in the denominator and 180 in the numerator. Okay, so notice how you flipped. Upstairs it was pi over 180, and now it's 180 over pi. So right off the bat, we can see that pi radians are going to cancel, and then you are left with 180 degrees over 6, which reduces whether you do mental math or put it in the calculator, to 30 degrees. So pi over 6 is merely 30 degrees. Okay? Very, very straightforward and easy. Now that's one way students do it, but recall also that I had told you earlier that pi is equal to 180 degrees, or 180 degrees is equal to pi. Remember that? Well, what some students prefer doing is, if they know pi and 180 degrees are the same equivalent value, here's another method they do this problem. So if I take problem number 12, okay, and instead of writing 23 pi, and I replace pi with its equivalent value, which in this case in degrees is 180 degrees, some students prefer this method of substitution. So all they did was replace what originally was pi, so this was my pi originally, right? They erase it, so to speak, and substitute it. And then right off the bat, they just type that into the calculator. So on this one, let's switch to our calculator, 23, 180, and 6. So we're going to come over here. Again, let me clear this out. Alpha y equals, we put 23, 180, and 6 in the denominator, if I recall. And when I hit enter, I get 690 degrees. So 690 degrees is what 23 pi over 6 is equal to. Okay, so you choose the method you prefer, whether you like the method in problem number 11 or the method of problem number 12. Just be consistent on practicing with the method of choice. All right, so if you would, let's have you practice 13, 14, and 15. Be consistent, doing the same method every single time so you get some practice. Pause the video right here and come back to check your answers. Thanks for pausing. Welcome back. Check problems 13, 14, and 15. And here's hoping again that you got them right. So the remaining problems you can use for practice, and you will also have additional practice in Delta Math. All right. So this is your first handout that I've given you. So let's move on to the second handout. Turn to the handout with the blank unit circle. Okay. So here is this unit circle that I'm going to have you guys work on today with me. And we're going to fill this unit circle out. Now what you guys are going to notice is in the near future, you will be able to fill the entire unit circle out in under 10 minutes. You will be asked to fill it out within a certain time frame, and I'm going to give you this exact sheet, except at the title, the title is going to read Unit Circle Quiz. And you will be able to fill this out completely. So we're going to walk through it in a slow way to show you how this is done. Okay? So again, the unit circle has angles measured in degrees and in radians. So we're going to first work around this unit circle and label our angles in degrees. Now, in past math classes, geometry especially, you learned that one full revolution around for a circle is comprised of 360 degrees, okay? Now, this particular unit circle, we are going to label it for one revolution, but I do want you to understand that actually, if I wanted to look at angles that were larger than 360 and just kept going, I can continually do that, okay? So, but we're focusing on one revolution, okay? 360 degrees. So, I want you to take a moment and possibly even visualize this unit circle as a pizza that's been cut into slices, all right? Now, here's what I want you to notice. How does special right triangles work with unit circles, okay? So in 6.2, we worked with the 30, 60, 90 and the 45, 45, 90 degree triangle. So you don't need to draw what I'm drawing here. I just wanted to draw this and ask you, what do you think this triangle, whoops, sorry, I lost my, let me actually draw it and I can always erase it. This triangle right here, which triangle does it look like? Which special right triangle? Does it look like the 30, 60, 90 or the 45, 45, 90? Which one does this look like? This one right here in blue. Does this look like the 30, 60, 90 or the 45, 45, 90? Okay? As you work your way through this right triangle business, each one of these segments is the hypotenuse of a triangle, okay? And it works its way all around. And you will notice that they're going to alternate between the two special rights, okay? So if you guessed that the red one was a 30, 60, 90, you are correct. This angle right here is 30 degrees. If you guessed that the blue triangle, this interior angle was a 45, 45, 90, you are correct. That was the 45, 45, 90. And then you switch back to the black one, which is kind of harder to see when I have these are all in there. So I'm going to erase this so you can see it a little better. This one here, this angle is the 60 degree angle. And this time it switched because this one was the 30 in the top here, the 90. So that's a 30, 60, 90. So all this information is kind of collectively put into this unit circle. So what right now, I want us to go back to focusing on the fact that this triangle right here is the 30, 60, 90. Okay? So let's go ahead and label. So the first angle from here to here was 30 degrees, okay? So I'm going to write 30 degrees right here on this line, 30 degrees. So what I want you to do is imagine that your pizza slice is this width and length, okay? Or this wide. So I need you to count in increments of 30. So that means the next increment of 30 slice is going to be this piece right here. And so what's 30 plus 30? Well, 30 makes 60, so I'm going to make a 60 right here. Okay? And then if I do the next 30-minute increment, 30 degrees out, that means I'm going to mark this as another 30 degrees is 90. And by the way, I should have written here 0. We started at 0. Okay? And so keep that equal spacing, and I want you to work your way around. Okay? So you are consistently adding by 100 degrees, by 30 degrees. Okay, so plus 30, and you're making your way around. Let me raise this up a little bit. And you will see that you are going to end up at 360 degrees. Okay, because you made one full revolution, okay? 30, 60, 90, 120. So all you did was continuously add by 30 degrees, all right? Now, notice that you skipped a few lines. You had skipped this line angle, and you skipped this one right here, and this one, and this one, okay? Those 4 are missing, so we have to go back and fix those. So this one right here, this hypotenuse belonged to this triangle right here. And you guys told me that that angle right here was a 45 degree angle, okay? So I'm going to label that actually in red just for it to stand out. This here is 45 degrees. So you did the 30s increments first, and that one's 45. Now instead of adding by 45s to make it such a big number to add by, I want you guys to notice that, whoops, sorry about that. Let me go back to my screen. Oh, did I just, hold on. Okay, I'm back. All right, here we go. Now it's sending me questions. All right, so here's what I want you to notice. From here to here, if I went from 30 to 45, what is the distance in measurement in degrees that I traveled? That is just 15 degrees, right? That was just 15 degrees. So from here to here was also 15 degrees, 15 degrees. So instead of counting by 45, I can go find those missing pieces very easily by just adding 15 to the smaller angle. So between 120 and 150, if I added 15 to 120, I would make 135 degrees and find that missing piece. Between 210 and 240, if I add 15, that will be 225 degrees. Between 300 and 330, if I add 15, it will be 315 degrees. Okay, so there you go. There are all the angles in degrees for all the angles. Okay, so right now, if you had done this on the unit circle quiz on the future, you would have a 33%. Okay, you have 1/3 of the test of the quiz completed. So those are your angles in degrees. Now let's work radians. Okay, here's how you do the radians. So let's convert, the first angle that we worked with was the 30-degree angle, right? So let's convert 30 degrees into radians so that we can proceed from there. So 30 degrees converts into radians by multiplying by pi over 180 degrees. And so my degrees will cancel, and I'll end up with 30 pi over 180. And I'm going to save the calculator part. If I type that into the calculator and reduce it, if you can't reduce it in your head, the zeros cancel, 3 over 18. That becomes 1 over 6 pi, or pi over 6, however you want to say it, okay? So 1/6 pi or pi over 6. So right here next to the 30, let us choose a different color. We are going to find a color that stands out. So let's use purple, all right? So 30 is the same thing as pi over 6. So I'm going to put it right there. And by the way, let's start with 0 radians as well in purple. So we start at 0. So from here to here, we know is pi over 6, the same distance. So we are going to make our whole round about counting until we get one full circle. So if this is 1/6 pi, when I do to the next line, I have to end up at 2/6 pi. So this is going to be my 2 pi over 6. After 2 pi over 6, then this has to be 3 pi over 6. So notice all I'm doing is counting. 1, 2, 3, and I'm making sure to state that I'm counting in pi over 6 units. After 3 pi over 6, this is 4/6 pi, 5/6 pi, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. That's all you do. Just count. And notice I counted in increments of 30 and I still have the missing 4, and I'll show you how to do that in a second. But that's all you do. All right. Now the one thing I do need you to do is, since you wrote them in fraction form, you are going to need to reduce the fractions, okay? So you're either going to reduce by dividing by 2 or dividing by 3 on some of them. So here's what I mean. So when you look at pi over 6, you can't reduce that any further, but look at 2/6. So right over here, let me get my little highlighter. See this number right here, 2 over 6? You can reduce that to what? So I can divide those both by 2. So this reduces to, I'm going to cross this out, and actually it's going to reduce to pi over 3. So pi over 3 is what you would write on the quiz, okay? How about 3/6? 3/6 can be reduced because they both can divide by 3. So I would replace this with 3 divided by 3 is 1 pi, and 6 divided by 3 is 2. So 3 pi over 6 is the same thing as pi over 2. 4 pi over 6, and you keep doing that, okay? So I'm going to cross this out, divide by 2, so 2 pi over 3. How about 5 6? 5 6 cannot be reduced, so we will keep 5 6 as it is. How about 6 pi over 6? Okay, well, 6 pi over 6, the 6's cancel. So it turns into a pi, and that makes sense because didn't I tell you that 180 degrees is pi? So that matches out quite nicely. 7 pi over 6 can't be reduced. How about 8 6? Those are both even numbers. So let's reduce that. 8 divided by 2 is a 4. 6 divided by 2 is a 3. So erase that. 9 6. So notice how you are dividing by 2's or by 3's. This becomes 3 pi over 2. 10 6 divided by 2. So that's going to be 5 pi over 3. 11 6 does not change. 12 over 6. I'm just going to erase it on this one, and that becomes 2 pi. Which makes sense because 2 times 180 is 360. Okay? So when you do this on the test, I keep saying test, on the quiz, once you reduce it, erase the one that you originally had. Okay? So this is what I would want to see. Erase this and just put pi. I would want to see the reduced fractions. Okay. And so there is your new one. So when you, on your note-taking guide, don't erase it, okay? Because you want to know how you got to where you got there. But just remember when you're practicing, I do need you to erase and put the reduced fraction, okay? All right. So pi over 3, so this was 1 6. Sorry, I lost my thing. 1 6, 2 6, 3 6, 4 6. So this is 2 pi over 3. Okay. All right. So I was just fixing the numbers here. So anyway, so yeah, so you'll just clean it up on the unit circle. And so notice every single one of those fractions are reduced fractions. Okay. Now let's go and fill out this one right here. This one right here, this one right here, and this one right here, just like when you did it with degrees, okay? So this one we have established is the 45 degree. So let's go back upstairs here. Let's see, this is space over here. And let's convert 45 degrees into radians. So pi radians over 180 degrees. So when you do the math on this one, you're going to get 45 pi over 180. That reduces to 1 pi over 4, or if you want to just call it pi over 4. Okay, so this one right here, let us use a green so it will stand out. This here is going to be pi over 4. All right, so what you're going to do is you're going to count in 1/4. So 1/4, 2/4, 3/4, 4/4, but you're only going to have to fill it out 3 more times, okay? Because those are the only ones missing. You're just missing this one, and this one, okay? So let us count in fourths. Now, from here, the 0 to right here, that's 1/4, okay? So from here to here was 1/4. So from here to here would be 2/4, but I already have an answer for 2/4 because 2/4 reduced to pi over 2, right? There, it's right there. So after that, you know what? Let me do a highlighter so you can see. Here was 0. Here was 1/4. Here's 2/4, but we already have an answer. 2/4 is pi over 2. So we come over here to another section. That's going to be 3/4. So I'm going to put 3/4 right here. And then I'm going to go a little further fourths. Right here, that's 4/4. Well, 4 pi over 4 is pi. I already have an answer. After 4/4, it's 5/4. So 5/4 was blank, so I'm going to put here 5/4. Then keep going around. Another increment. This is 6/4, but 6/4 is already done. Here's another one, 7/4. That's missing. So let's put 7π/4 here. And then you make your way back to 8π/4, but 8π/4 is 2π. So you end up filling it out. Let me diminish this a little bit so you can see how the increments stayed the same. Okay, so always make sure you're counting in the same increments. So notice now you have every single one of those lines numbered off for degrees and for radians. So now you have completed 66.666666% of the entire unit circle. So right now, rounding it off, you have made a 67 on your circle quiz so far. Okay? Now, here's the last portion. So if you are tired at this point in the video, may I suggest that you take a break? Okay? What I'd suggest is probably step away, give yourself a brain break. It's been going on for half an hour, and come back so that we can find how to determine the coordinates for each one of these dots. Okay, each one of these dots are the endpoints to a part of your right triangle, and they have lengths that are going to be associated with X and Y coordinates. Okay, so I'm going to show you a shortcut on how to come up with those coordinates. So like I said, take a break, pause the video here, and come back. Okay, so hope you took a brain break. Here we are going to continue. All right, this lesson is a long lesson, so I apologize for that. Okay, so each one of these dots is going to be represented by an X and Y coordinate. Now here's the reason why. So you'll notice that I erased my circle. You can continue writing on your circle. I erased it because I wanted to declutter so that I can do some drawing to help you understand what I'm doing. But just continue drawing on your circle, all right? So don't do this part, but right now, again, redrawing this 30, 60, 90 degree triangle here that we're talking about. Here's what, in essence, you're doing. Okay, so here's this dot, and this dot is going to be an X and a Y coordinate, okay? So what I'm asking you to do is, if you started right here where this darkened dot is, what that I just drew, you are traveling this distance this way. That's X distance, right? And then you traveled this distance up to get to that point. That's your XY distance, okay? So doing it again, this here was your X distance, and this here was your Y distance. Now you know, because this is a 30, 60, 90 triangle, 30, 60, 90 triangle. Across from the 30 is a 1, across from 60 is a square root of 3, and across 90 is a 2. So if you were trying to come up with the X and Y distance, you basically traveled square root of 3 units to the right. Okay, let me do that again. Square root of 3 units to the right, and you traveled 1 unit up. Okay, but what mathematicians decided to do was, this is called the unit circle. Okay, and since it's the unit circle, unit means 1, uno. They said every single one of these radii, okay, a radius is the distance from the center to the edge of the circle, is a length of 1 unit. Right now, based on this triangle, I have the radius being 2 units in length. So what they decided to do was this. They said, you know what, let's divide everything by 2. And so they divided this by 2 to make it a 1, divided this by 2, and they divided this by 2 so that the radius of the hypotenuse was a 1. So now, notice what happened. the distance you traveled to the right was square root of 3 over 2 units, and the distance you traveled up was 1 over 2 units. So right here, the coordinates were square root of 3 over 2, comma, 1 over 2. And that's how they came up with that coordinates for this point right here, okay? Now, I don't expect you to draw every single one of those triangles to figure out every single one of these coordinates, okay? So I just wanted you to understand where those distances came from, and I'm going to show you now how to figure it out or how to fill it out in a quick way, okay? So watch what I'm going to do. Let me erase these and we will start. Okay, so here it is all cleared up. So let's start. So again, I told you that the radius of all these segments is a 1, okay? So let's pretend to consider this like the origin, okay? So if I go to the right 1 unit, because that's the length of my radius, I am going to say that this coordinate right here is a 1, comma, 0, okay? So I'm going to have you always do the 4 right angle coordinates, okay? So the next one is this one. You have to go to the left 1 unit, and you don't go up or down. So this coordinate here is going to be, whoops, this coordinate here is going to be -1, comma, 0. Okay, so you went to the right one, to the left one. The y distance, you didn't go up or down. Now this one up here, that's going to be 0, comma, 1, because you started at the origin and you didn't go left to right, you just went up 1. And this one right here is 0, comma, -1. You just go down. Okay, so you already finished 4 of them. Now let's figure out how to do the other 12 points remaining. So here's the little trick that I want you to understand, and how you can just do these rather quickly. So we're going to try and get these 3 done in the first quadrant. Now I want you to remember, in the first quadrant, I'm going to make this a little bit bigger, my coordinates in the first quadrant will always be positive and positive, right? X and Y is always positive. So when you make these coordinates, you are going to notice that all these numbers are going to be fractions. So when you're taking the timed unit circle quiz, just go ahead and draw the little fraction bars for yourself, because they're all going to be fractions, okay? Guess what they're also all going to be? For denominator values, they are all being divided by 2. Remember why? Remember we divided the hypotenuse by 2 to force the radius to be a 1? So every single one of those numbers will be divided by 2. Now, here's the little trick to make it easy. Start up here at the upper top dot and start writing a 1 and work your way down. 2, 3, and then I want you to reverse count 1, 2, 3. Got it? That's all you do. I'm going to do it in red. Start here, 1, 2, 3, reverse count 1, 2, 3. Once you have done that, I need you to apply a square root to all the numerators. Now, the reason I don't really do square root over this one, because square root of 1 is just a 1. So even though I put it, it disappears because the square root of 1 is 1. Put a square root around square root of 3, square root of 2, square root of 3, and then ignore the 1. And you're done. Those are the 3 coordinates for that first quadrant. That easy, okay? So your question may be now, well, how do I keep doing all the rest of them? Super easy. All you're going to do is whatever this dot is, coordinates, that will go to that one, this one will go to this one, and this one will go to this one. Just map them over. but this is what you need to remember. Second quadrant, your x's are negative and your y's are positive. So you must keep those signs, okay? So if I map this one over to this side, I'm going to write 1/2 as negative, and the y value square root of 3 over 2 stays as is. So let's do that. I'm going to go ahead and put parentheses and do this for every single one of them again, because I know they're always going to be fractions. So this is what I tell students when they're taking the quiz. Go ahead and draw all of these, and then just go ahead and just do these really fast, okay, because you know all the denominators are 2. All right, so here we go. This comes over to this one, so it's going to be -1, and that stays the same, square root of 3 over 2. Negative square root of 2, and this is positive. This is negative square root of 3, and this stays positive. Okay, so notice all I did was write, I just mirrored it. I just, like if I folded my paper over, that's what those dots are going to be. Now, let's go to the third quadrant. Let me make this a little smaller. So now, what you're going to do is map them over to the bottom part. Okay, so we just did these 3 dots here. And I'm going to map them to these 3 dots here. Okay, so this dot will go with this one, because I'm bending the paper over. This one will go here, and this one will go here. Okay, again, fraction, so I'm just going to go write all my little fractions. I'm going to put my parentheses. I'm going to put my 2's. Okay, all right, let's map them. So this dot will go right here to this one. But now we know in this quadrant, I forgot to mention, my x's are negative and my y's are negative. Okay, so this one here is going to stay negative, and this one becomes negative. This one is going to stay negative, and this one becomes negative. Right? So let me make it smaller again so it's easier for you to see how it's mapping out. All right, so notice this one came down here, this one came down here, now this one is coming down right here. Those two are going to become negative, so negative stays, and this one is negative square root of 3. And then we are going to go to the last one, and believe it or not, you are done filling out the unit circle. That's all it is that you need to practice for your future quiz. These are going to go this way. So fold over again. You can do this, or if you prefer, some students take it and they go, well, I'm going to do this one with this. No, did I do that right? Sorry. This one with this one with this, and this one with this. So you can either or, doesn't matter. But in this quadrant, we know that our x's are positive and our y's are negative. All right. So let's, again, parentheses, 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 lines of division for our fractions. I know they all have 2's. And I know this one's going to be negative. Okay, so let's map them over. So this one here is going to be a positive square root of 3, negative 1 over 2. This is going to be positive square root of 2, negative square root of 2. And this one's going to be a 1/2 and a negative square root of 3 over 2. Okay, and that is the third missing section for our unit circle. All right, hope you are understanding this. Okay, hope it's a little bit clearer as to what direction we're going in. Now, here's what I want you to do before you take off here. Would you please, let me move this over. There's a key right here that I've written. please write this down somewhere on your unit circle. You are going to use this key to be able to read your unit circle, but we will do that on part 2 video of 6.3 notes. So just go ahead and write this down somewhere for easy reference, and I'm sure I will rewrite it again on the next notes. Thank you for watching, and well done.